Today, we're going to talk about one of the most powerful, but also most overlooked sources of renewable energy on the entire planet. It's called OTEC, and it's a technology that wants to turn the ocean itself into a giant clean power plant.
All right, let's just jump right in with a pretty wild idea. When you think solar power, you probably picture shiny black panels on a roof, right? But what if I told you the biggest solar collector on Earth isn't made of silicon at all? It's made of water. Yep, the ocean, covering over 70% of our planet, soaking up a truly staggering amount of the sun's heat every single day. And all that absorbed heat, well, it basically turns the ocean into a massive thermal battery. But how do you plug into that? How do you actually get the power out? Well, the secret isn't just the warmth itself. It's the difference in warmth. Think about it. In tropical areas, the surface of the ocean can be a really pleasant 25 degrees Celsius, kind of like a warm bath. But if you go down just 1,000 meters straight down, the water is a near freezing 4 degrees Celsius. It's a completely different world down there. And that difference, that thermal gradient, is a huge, untapped source of energy just sitting there. And this is where our hero technology comes in. It's called Ocean Thermal Energy Conversion, or OTEC for short. At its heart, it's a heat engine, but it's a very special kind of engine. It's designed to generate electricity from nothing more than that simple temperature gap between the warm surface and the freezing deep.
Now, you might be thinking, hold on, most heat engines, like a coal plant, they need incredibly high temperatures, hundreds of degrees to work. The absolute magic of OTEC is that it can run on a temperature difference of only about 20 degrees Celsius. So how on earth is that even possible? Well, the answer lies in not using water. Instead, you use a special working fluid. The secret ingredient here is ammonia. And the key thing about ammonia is that it has a very, very low boiling point. That means you don't need scorching heat to turn it into a gas. In fact, that warm surface ocean water, it's more than hot enough.
So here's how the most common setup works. It's called a closed cycle system. First, you take that warm surface water and use it to boil liquid ammonia, turning it into a high-pressure vapor. That vapor then shoots through and spins a turbine, and boom, you're generating electricity. Next, you pump up that freezing cold deep ocean water to cool the ammonia vapor down and condense it back into a liquid. And finally, you just pump it back to the start. It's a continuous, clean power loop. But get this, generating electricity is only half the story. There's another version of this technology that comes with, well, an almost magical side effect. It's a total game changer. So instead of using ammonia in a closed loop, what if you could use the warm seawater directly as your working fluid? That's the whole idea behind what's called an open cycle system. If you put the warm seawater in a low-pressure vacuum chamber, you can actually make it flash boil into steam without needing any extreme heat. That steam spins a turbine to create electricity just like before. But here's the magic trick. When you use that cold, deep ocean water to condense the steam back into a liquid, all the salt gets left behind. So what's the result? You get two incredibly valuable things from one single process: reliable 24/7 baseload electricity and pure, desalinated, fresh drinking water. Okay, so a system that gives you 24/7 power with zero fuel costs, and it can even make fresh water out of thin air. Or, well, out of seawater. You have to be asking yourself, why isn't this everywhere? And this, my friends, is where we run into the massive, massive challenges that have kept this incredible technology mostly on the sideline. And the scale of the challenge is just so frustrating because the potential here is immense. I mean, theoretically, the thermal energy just stored in the ocean is so vast that OTEC could power our entire civilization. Twice. That's just a staggering amount of clean energy. But, and this is a really big but, here's the catch. Because that temperature difference is so small, OTEC's efficiency is incredibly low. We're talking only about 3 to 5%. Compare that to a coal plant, which can be around 40% efficient. So what does that mean? It means to generate a useful amount of electricity, you have to move truly colossal, mind-boggling volumes of water. And that leads us to the single biggest obstacle, the main villain of the OTEC story, the cold water pipe. We are talking about a pipe that has to be a kilometer long, it needs to be wide enough to drive a truck through, and it has to hang from a floating platform in the middle of a storm-tossed ocean. Just think about that. Building and maintaining a structure like that is an unbelievable engineering and financial challenge.
This isn't just some small technical problem. It's the absolute heart of the issue. It's what some have simply called the engineering nightmare of OTEC. It is the one component that makes the whole thing so difficult and so expensive.
But the story doesn't end there in failure, because while OTEC might not be a global silver bullet, its biggest weaknesses start to disappear when you find its perfect home, and that home is in the tropics. For tropical island nations, places like Hawaii or the Maldives, the whole equation is completely different. These places often depend on ridiculously expensive imported diesel fuel to generate their electricity. For them, OTEC isn't just an other option, it's a holy grail. It represents energy independence, stable prices, and a desperately needed source of fresh water.
So when you lay it all out, the picture gets pretty clear. The disadvantages, yeah, they're significant. Low efficiency, huge upfront cost, and it only works in certain places. But the advantages, for the right location, are absolutely transformative. Free, infinite fuel, constant baseload power that works when the sun isn't shining or the wind isn't blowing, and that amazing bonus of fresh water.
You know, OTEC really is the sleeping giant of renewable energy. The potential is there, the resource is practically infinite, and the technology fundamentally works. But those engineering and economic hurdles are just immense. So the real question remains, what will it take to finally wake this giant up?